Hello guys, Jamal here. In this video I would like to share about solver like I mentioned in the previous video. Okay, before we start this tutorial I would like to check if solver is already installed in your Excel. Okay, first we open in file an option, add in, and then we go to Excel add-in and go. There's a bunch of tool, analysis tool pack, analysis pack VBA, euro currency tool, solver add-in. You can check all, checklist them all, and okay. Okay, after the installation of solver is done, let's check what inside the solver. In the solver there is some feature. Let objective value, maximum, by changing variable, and constraint. So what is solver actually do? So solver is a tool in Excel that help us to compute an optimal solution of a case. The most famous way to use solver is to optimization process on linear programming, but you can also use in many other way. Okay, let's in this section I would like to share you about the problem. Okay, we have so this problem is already in mathematic form, but actually this form should be an storytelling form. Let's take a screenshot. And then we copy them, go back again to Excel. Okay, first thing you need to create in the solver is the objective value. There is a maximum value and it has many constraints. St is constraint. Okay, let's create the equation in Excel. First, let's call this variable. There is two variable, x1 and x2, and we want to know the value of variable x1 and x2 that satisfy all of constraint. Let's say unit, and there is objective function for max. Let's say because the max z sama dengan equal to 3x1, so we type 3 and the second is 2, and then we create a constraint equation. Let's call it st, and then it's st1, st2, and there is 1 2 3 4 5. There is 5 constraint, but we only make it 3 maybe, because I will tell you later about this restriction. Okay, the first constraint is 2x1 plus 1 x2 less than 100, less than 100. The constraint 2 is x1 plus x2 less than equal to 80, 1 less than 80, and then x1 less than 40, x1 and x2 more than 0 or non-negativity. So in this case we count the value, multiply value we got in x and all the variables that satisfy with all these constraints. Let's say we start from 0 and 0. So what the value of maximum z when the unit of x1 and x2 equal to 0? So we count by some product. And don't forget $sign. Okay. And then let's delete it. I would like to mark in color yellow maybe. Okay, green. Okay, so let's go to the solver. Okay, like I mentioned before, there is a menu we call filter or menu. Let's set objective. Our objective value is this one, the product of x unit in x of x1 and x2 times x, the value of objective function. Let's enter and press enter to maximum or minimum. In our case, it set to maximum value. We changing variable, this variable, and we add constraint. First constraint, the first constraint less than 100. We add more, less than 80, and the last constraint more than less than 40. Okay, and make constant variable non-negative. So the variable of x1 and x2 in this problem set to non-negative or more than 0. That include these two constraints. GRG nonlinear for nonlinear problem, and there is an information about this method. Okay, we set to simplex linear program, and then solver. You can save the answer, but let's keep in mind just report save. Okay, after the solver we get the maximum value is 118 with x1 equal to 20 and x2 equal to 60. Is that satisfied with our constraint? Of course, it satisfy because it no more than 100 and in this one no more than 80. The answer report. Not a big problem. The binding mean is that we use all the resource we have, or there is some resource left. Binding, actually this solver is overkill to solve two variable problem because we can use more efficient way with graphical method in mathematics. Let's check our answer with mathematical method. We will use let's use GeoGebra. Okay, here we already in GeoGebra pen. Let's set this like this. Okay, in GeoGebra we don't use this objective function, we only use this constraint equation. First, x plus y plus then 100 x plus y plus then 80 x plus then 40 x less more than 0 y more than 0. It's the overkill also. Let's zoom out. Okay, I would like to choose the color in setting. Okay, by graphical solution, we determine the solution from. Okay, the first point is, let's say, point A, x1 and x2 are in our graph topology y. Point A is 0, 0, and point B is what the position in here, what is that, 40, maybe 40, 0. Point C in 20 and 40, 40 and 20, and D is 60 and 20, 20 and 60, and the last E point 80, 0, 80. So this point A is impossible that become a maximum value. And then let's check the 0, 40, 0, 40, 0. It has 120,900, and then 20, 160, and last we have 20 and 60, 180 and 0, 80, 160. So we know that the maximum value is in point D, which is 20 and 60, which is the same value we got in solver. Okay, maybe just for like that. It will be in the same way if we use like in 3 variable, like let's say we add some value x3 and it set to 1 0 and 1. Let's say it's just when it comes to 3 or more variable, the graph, we cannot contain this, we cannot solve this problem with graph method because there is more than 2 axes. So this solver very useful to problem with more than 2 variable or 2 axes. Okay, let's say some product $signs 2. It's bit error. Okay, let's try again some product to x3, enter. Okay, with the same constraint, let's say what we got. Reset the objective value by changing this variable. Add first constraint less than 100 and second less than 80 and then the third less than 40. Use simplex non-negative and then solver. Okay, keep the answer. With this more equation, more axis, more objective value or more variable to specify our product, we got this 200. Okay, maybe just that for this video. Thank you for attention and don't forget to subscribe and share this video to your friend. Thank you. Bye bye.